Welcome. We want to take a look at what an inverse function is. Now, texts introduce this in various ways. Some of them introduce what's called the inverse relation, and then we make the refinement again, is this relation a function? And I believe that's what our current text does, whereas the definitions I've given in the past first rely on the restriction to only consider functions and not just not inverse relations in general. So let's consider, we'll return to this definition in just a moment, but let's look at the inverse relation. So what is an inverse relation? Well, an inverse relation is found by exchanging the order of the ordered pairs, right? A relation is a collection of ordered pairs. Its inverse is simply found by exchanging the first and second entry of those ordered pairs. So if we have a relation given by 1, 2, 3, 4, 5, 6, right? Not very interesting. Then the inverse relation would be given by exchanging the x and y coordinates. So 2, 1, 4, 3, and 6, 5. I've simply exchanged the x and y coordinates from each of the ordered pairs. Now, this was a function, and the inverse relation here is also a function. So here's a function and an inverse function. So that's cool, right? We can take our conversation of relation, talk about inverses, and then again make that same restriction to is what we have a function. We could also consider the relation given by the equation y equals x squared minus 3, for example. The inverse relation, right? If we exchanged the entries in our ordered pairs, first entry is x, second entry is y, then what we're doing is we're exchanging the x and y coordinates. We're exchanging the values of x and y. Exchanging x and y, right? So I phrased it differently each time there, so that way we could get to this idea that we're simply exchanging x and y. Now, this relation does turn out to be a function. However, this inverse relation is not a function. So we won't always have that the inverse relation is a function. And the question is when do we have an inverse? Well, it works out, an inverse function. It works out to be that if our original function has this characteristic of being one-to-one, then the inverse will in fact be a function. So we don't necessarily have that understanding yet of what it is to be one-to-one, and we're going to look at that in just a moment. But when we have this characteristic of being one-to-one, we simply define the inverse function as exchanging inputs and outputs. So if f of a is equal to b, then we exchange this input and output to get the inverse. So this introduces for us function notation, the inverse function notation. F to the negative first power, that is f inverse of b, is equal to a, if and only if f of a is equal to b. So since we've restricted ourselves to using function notation, we want to restrict our viewpoint to when does our function have an inverse function, okay? And that is satisfied when our original function is this thing called one-to-one. We'll look at that in just a moment.